We've just finished with an example where we found ourselves with a problem where we would have to create another finder class with another find item inside of it as a function to accommodate the types that we're passing in as parameters, right? A list of strings, if we want to do a list of objects in general, or a list of integers or boolean, we'll have to duplicate that code. And I'd said that there is something that will save our lives, that will make us having less code or less code repetition, which is real good. And I said that type is generic type. What is a generic type? Well, as the name implies, generic means it's something generic. It's not specific. Okay? And in many cases, being unspecific is not a good thing. But in this case, it's great because it gives us this flexibility of passing in any type that can be received within the function, or in this case, a class, and still work. So a generic type is a flexible class or interface that is parameterized over types. So what this means is, instead, for instance, if we were to create a class, right, that we know that we need to pass a parameter that it accepts. In this case, we'd say box, and we put inside of angular brackets or angle brackets like this string to say this box is going to contain, this box has a parameter of string in this case, right? And of course, we have a constructor, primary constructor, and we have also a parameter that we're passing of type string. So this box here will only accept string types. That's how we parameterize this box, which is not very helpful, because if we want to create a box with integers, for instance, then it's not going to work. It will work, but it will have to create another box class and pass a parameterized integer, which is not a good thing. So instead, with generic types in Kotlin, we can do this. We can say box, and inside of angle brackets there, we can put a t, right? And we can also pass, as in our constructor here, as a type t also for our property. So what does t stand for? T is just a type. So it's a generic type. Could be a string, could be a person data class or object, could be a car, could be whatever we want it to be. Of course, sometimes you can have some restrictions, but in general, it will accept whatever we want to be. Okay, so that is our saving grace. Let's take a look in code. How do we transform our finder class so that it can accept other types as well and still work? That is the key point. Okay, let's go ahead and take a look. So back here, we have that problem, right? Because I tried to create a list of numbers and pass in some numbers, and when I pass inside of a finder, then we have this issue here. So not very helpful, because it's saying, well, finder, I don't know what you're talking about, because I can only accept a list of strings, because that's the contract we have in our finder class here. To change this is very simple. So what we can do in our finder, we're going to add the angle brackets and say t, and then we're going to change this as well to t as such, changed element to t, and change this element inside of our found item function to t as well. All right. Of course, we have a little problem here because it's saying finder.item element here. It's not understanding, because we passed the list of numbers. This makes no sense because this is a string. So we need to pass our in this case here, let's say we want to pass 23, because that would be the integer we're trying to find. Just like that, we didn't have to do much really. If I go ahead and run this, found 23, and it works. If I try to find 233, which is not part of our list, we should see a null, hopefully. And voila, found null. Very good. And we've solved our problem just like that, because we understand how generics work. We're passing a t to say this t can be anything, any type, right? And our list here, we also have to pass the t to say, yes, we're accepting the type t. Whatever we pass here obviously has to be uniform everywhere else, right? And in our element find item here, we're also passing t. And for our found item function here, which ends up being a lambda later, right? see here, int with exclamation point, which means it's going to be nullable, and we can pass and get that it like that there. Okay, we didn't have to change much. We could also, I'm going to go and find our old friend here. Let me get this list of people just to show you here that this still works. So I'm going to put this back there. So we created a person. This is the previous lesson where we create a data class, right? Data class, and then put that on a list. So list of people. I'm going to use that list of people to pass inside of a finder here. I'm going to have a little problem because it's going to say this is makes no sense. So in this case, let's go ahead and say Ruti, because that's one of the people that we have there. Let's go ahead and run. You can see, said found person, name Ruti, last name Ashava, age 54. And you may say, okay, why is this still working even though we didn't come here and say something like this, right? We want person types. Well, the reason being is because the moment we pass these types inside of this function here, right, or class that is, it will be inferred that indeed that is the types that we are looking for, because these types are the ones that are being propagated inside of our find item to look for something. But as I said here, that we can remove this. In fact, we should, just to make our code cleaner, because it is explicit type arguments. So we can just remove that and that's fine. Okay, so there you have it. So whenever you want to avoid code duplication in this sense, consider using generics, because they will save your life. So this was the basics, entry level of generics. Of course, there's more to learn about generics, and I would encourage you to do some research, say generics, Kotlin, so you can learn more the idea of what generics are and what else can you do with generics. One thing to keep in mind is that you can pass different types here, right? It's not just that we can pass just one. You could put dir x, y, and so forth. And of course, accordingly, you'll have to change things around so that these new types, these new parameters that we're passing, can actually be used. But the main idea is that you're not limited to just passing one type at all.